Okay, let us now continue with the rest of the problem solving in the workbook. Okay, let's continue with page, now in this case we're at page 63. Okay, turn to page 63, okay, which is on the next page. Okay, the next page is on how do we apply, okay, the conservation energy to solve GPE and KE question. Okay, so in this case they might give you a scenario. So in this scenario it's actually a crane. Okay, so there's a crane of 8 kg, so this is your mass of 8 kg. So once you see some information, you record down. Okay, write down mass is equal to 8 kg. It's released from the top, so it started from the top, okay, and slides to the bottom. So very important, start from the top. Okay, in this is over at this position and slides to the bottom as shown in the diagram. So from the top to the bottom. Okay, so first part it asks you to calculate the GPE of the crane where it's at the top. So at the top means it has a height. So can we take note? When you talk about GPE, it's always talking about the height difference. So don't use other length, just use the height, which is 3 meters. So this part is very important because it's a vertical height. Okay, so take note, this is vertical height, not horizontal distance or diagonal distance. So in this case, apply your formula for GPE, which is mgh. So 8, which is your mass of your crane, times your G10 and times your height, which is in meters, 3 meters. So just press your calculator and your answer is 240 joules. Okay, let us now move on to part B. Given that the speed is 7 meters per second, so this is your V, where it reaches the bottom. Okay, bottom. So it starts to move from top to bottom. So it lose height, it gains speed. So write down lose height. Okay, because start to move down, so it gains speed. Okay. Okay, so it asks you to calculate the kinetic energy of the crane at that instant. At the bottom. Okay, instant means at the bottom. Okay, so please put an arrow. Instant means at the bottom. So you lose height, you gain speed. So what does it mean? Okay, you notice the speed is given here. So you can use the answer for the speed. Okay, so half mv squared is the formula for ke. So take your half times your mass, which is still 8, it's the same crane, and your speed is 7. So you must remember to square your 7. 7 squared. 7 squared is 49. So do take note, it's not 2 times 7, it's 7 squared, 49. So press your calculator, which is half times 8 times 49. Okay, so your answer should be 196, which is the modern answer here. Okay, so that's how you solve for KE. Just remember to recall the correct formula. Okay, what about part C? Okay, give a possible reason for the difference of the answers in A and B. So you notice in your answer for A is 240, but in your answer for part B is 196. So where is there a difference? Where does the energy go? So if you started with 240, you should end with 240. But in your calculation, you only get 196. So in this case, there's a reason for it, which is the slope is rough. So when there's rough, there's friction. So there's work done to overcome friction. So there's energy loss due to heat or sound. Okay, it can be heat or sound. Okay, because you need to do work against friction, and friction produces heat or sound, heat and sound. So in this case, this energy difference of how much, you take 240 minus 196. So what is the difference? Okay, press your calculator, you should get okay, open up your calculator. Okay, take 240 subtract 196. Okay, so the answer is 44. Okay, okay, answer is 44. So this 44 joule or energy difference is actually your energy loss due to heat and sound. Okay, so this is very important because principle of conservation says that energy cannot be created or destroyed, but it can be changed from one form to another. So now your GPE is connected to your KE plus energy to overcome friction, okay, due to and loss as heat and sound. Okay, so let us now move on to question 6. Okay, move down to question 6. So you need time to copy down the previous notes. Just pause the video and come back to this part later. Okay, okay, parts. Question 6. Okay, this is a typical example of the principle of conservation energy. It says that there's a mass pendulum with a certain mass of 20 kg. So this is your mass. Okay, it's released from point A. So this is point A. So when you solve the question, you must read very carefully. Identify all the information given. Okay, so 20 grams and start from point A. Okay, so this is your starting point. So you can label a diagram. Okay, part A. Calculate the KE of the bulk when it reaches B. So when the bulk starts to reach B, you will lose what? You will lose height. So you notice A to B, you will lose this height. So this is your loss of height. Okay, as it moves from A to B. Okay, this part is very important. So if you lose height of 30 cm, this is your height. Okay, it means that you gain speed. Okay, so now your loss of your KE, so we have the model answer. Your loss of your GPE, okay, your loss of your GPE because you lose the height is now being gained as your speed. So if you gain speed means you gain KE. So you apply the formula for MGH. You don't apply the formula for KE. A lot of students, when they see part A, straight away they try to write down the formula KE equal half mv squared, and they cannot solve. Okay, because in this question they did not give you the speed v. So if you don't have the number for speed, you cannot solve directly. So the way to solve this question is to use the MGH, because you lose the height means you gain the speed. So in this case, your gain in KE is actually your loss in height. So in this case, you have to use the formula for MGH and not half mv squared. Okay, this is a very common mistake by students. Okay, they straight away just recall the formula and they've forgotten everything about conservation of energy. Okay, that means you lose height and you gain speed, and the speed is now your gain in KE. So this part is very important. Okay, so in this case, you use the formula for GPE instead of KE. So half, in this case, you cannot use half mv squared. You have to use MGH. So you look at the working here. Mass is your 20 kg, but you notice something. You cannot use 20 grams. You have to convert 20 grams to kg. So in this case, just now 20 grams. How do you convert to kg? You take 20 divided by 1000. So you must add in this step here, because your mass must be in SI unit, which is kg. So in this case, you get 0.02 kg. Okay, so this part is very important. Convert to SI unit. Okay, you don't convert the mass to SI unit, your answer should be wrong again. Okay, so your mass, don't use 20 grams, you must use 0.02 kg. Okay, times your G on Earth is always 10, and your height, another conversion, because this is in cm. So how do you convert cm to meter? So 30 cm is equal to 30 divided by 100. So copy down the step. Okay, in meters. So answer is 0.3 meters. So this is another conversion. So these two parts you have to convert to SI unit. Okay, this part is very important. I give some time to copy down. Okay, the conversion unit from grams to kg and cm to meters. Okay, very important. After that, press your calculator, then you get your final answer, which is 0.06 joule. Okay, so you need time to copy down these steps. Do pause the video now. Okay. Okay, let us now move on to part B. Okay, calculate the speed of the bulk when it reaches point B. So when it reaches point B, means it has converted to all to KE. So now you use the formula for KE, which is half mv squared. So in order to find the unknown speed v, you have to input your KE that you got it from part A. So your part A answer for KE is 0.06. So you just put this in 0.06 and you apply a formula half n, and remember to use the correct unit for mass, which is 0.002 kg, and your unknown speed v squared. So after you reach this step, a lot of students are very confused. How do they reach from here to here? So I'll show you the steps now, the breakout. So first, write down 0.06 is equal to half of 0.02 is actually 0.01, right? Okay, then in order to put v as your subject, v squared will be equal to, you bring this over, so 0.06 divided by 0.01. Okay, and then your final step, v is equal to square root. You write down square root 0.06 divided by 0.01. So your answer should be 2.45 meter per second. So do copy down this step. How do you solve from v squared to v? So remember, you need the final step, which is square root, okay, to find your v. Okay, so do pause and copy down this step in your workbook. Okay. Okay, let us now move on to the last question that we want to go through for today. Okay, so the last question we want to go through for today is question 7. Okay, question 7 gives you some information which is very important. Okay, they give you the mass, so underline the mass, which is 250 kg. There's a vertical distance, which is your height. So you see vertical distance means this is your height h. Okay, 10 meter, and it's in 20 seconds. So 20 seconds is your time. And there's no need for any conversion because it's already in SI unit. So all these are already in SI unit. 10 meters, 20 seconds. So no need to convert. Even your mass M is already in SI unit. Okay, so no need to convert. So when you get any information, make sure that you get it in the correct units. Okay, when you do your calculation. And if necessary, need to convert the units. Okay, now look at part A. Calculate the power of the V. So power, you recall the formula for power. Use the triangle. Okay, power is actually energy on top, power and time below. So power is actually equal to energy divided by time. So in this case, what is the energy in this question that's being used to do work? So keyword here is raise, means you gain height. So you gain height means you gain GPE. So now your energy is actually your GPE. So you can actually change to this portion. Okay, power is equal to your energy to do work against the gravity. Okay, so this is GPE divided by time. So you look at the model solution here, straight away you'll find the work done to do work against gravity. So it's actually GPE. So you can write down this is actually your GPE. Okay, so GPE is equal to mgh. So m is 250, g on earth is always 10, height is 10 meters. So you just multiply and this is your answer. Okay, so once you have gotten your energy, you just apply the formula just now that I drew the triangle. So power is equal to energy or work done divided by time. It's all interchangeably. So you can put work done or you can put energy. Okay, so energy is in the first part here. So you plug in the number, time is 20 seconds. Okay, so in this case, you press your calculator, you get this answer. Okay, so that's for part A. Okay, now move on to part B. 4 60 watt light bulb are used to the V for 5 hours. Calculate the total amount of electrical energy consumed by the 4 lamps. So now they're asking you for energy. So same thing, use the triangle. Energy is power times time. So in this case, your power is now your watts. So you see watts unit means this is power. Okay, so power is 60. So 60 and there are 4 light bulbs. So 4 means times 4. Can you see? So your power now must times 4 because you have 4 light bulbs. Then times the time taken. So this is your power with 4 light bulbs. Okay, 4 light bulbs. And this is your time taken. Okay, and in this case, because it's 5 hours. 5 hours to convert to seconds. You have to convert 5 hours to minutes. So 1 minute is 60 seconds. Okay, 1 hour is 60 minutes. So you must multiply by 60 and 60 to convert to SI unit of seconds. So in this case, once you convert to SI unit of seconds, okay, so then you press your calculator. So this is your answer in joules, which is energy. Okay, so remember this is very important, and this triangle is very important to use. Okay, so remember to convert to the SI unit. Time is seconds. Okay, so must times 60 times 60. Okay, then next we move on to part C. Okay, they ask you the piano is pushed at a constant speed through a horizontal distance of 3 meters in a carpeted surface. Okay, if the average frictional force between the piano base and the surface is 15 Newton, calculate the work done by the applied force. So in this case, because it's constant speed means your applied force has to be equal to your friction, because resultant force is 0. Okay, your F is equal to 0. So your applied force that you're pushing has to be equal to your frictional force. So these two forces has to be equal. Okay, then your resultant force is 0. So in this case, the applied force has to be equal to your frictional force, which is 50 Newton. So this part is very important. So the work done formula is force times distance moved in the same direction of the force. So if your applied force is 50 and your horizontal distance moved is 3 meters, so you just multiply by each other and the answer is 150 joule. Okay, so that's the end of the explanation for the essential questions in the workbook. Okay, if you have any question, do come and ask me.